Hello, guys. This is Watching Singularity, where we break down different technical papers, academic perspectives, and just the general kind of movements and advances that are currently happening within artificial intelligence as well as machine learning. I work currently as a data scientist, and I basically will walk through the traditional different types of papers that I will read, and we'll read them together. So basically, today there was a very interesting paper that was launched by Nvidia called iGRPO. If you're familiar with GRPO, it's a policy optimization algorithm that's used in reinforcement learning in order to use a reward mechanism to try to improve the reasoning or the capability of LLMs. And kind of what Nvidia kind of added in this paper is that they used a new mechanism where they would iterate the group policy mechanism itself. And the mechanism in which would do this is that they would sample exploratory drafts, and then they would select the highest reward draft with, as a basically reward signal for the optimization step. By doing this, it kind of like leads to this feedback in loop that um, where it can lead to further and further refinements. We're entering this stage right now where artificial intelligence is entering this recursion loop where we take the outputs of the models and we kind of iterate them. We find what works and we reward what works, and we let this kind of cyclic system kind of keep getting better and better. So just as some brief overview of GRPO, GRPO is a value function free variant of proximal policy optimization. And the way that it basically works is it kind of gives a score, and it basically tries to maximize that score. And the mechanism is that it tries to basically optimize this GRPO objective function, which is given by this. And we're basically doing this by trying to minimize the KL, which is divergence, and minimize it as much as possible. And what basically NVIDIA done is that they introduced this iterative approach where now they would allow for a more dynamic reconditioning and allow the loop itself to keep iterating on itself to lead to finer and finer and more controlled reasoning loops. And let's just kind of walk through kind of like the basic algorithm as so far. It basically says you take a pre-trained model. You have a training set B that is a set QA and a reward function R not, draft count N and group size G, clipping parameter. Then basically you just iterate and then you sample the batch. So basically the first stage is you just sample the drafts. You can compute the rewards for each of the drafts in the reference answer. Then you select the best draft, basically that is the argment of those drafts, and then you basically augment a prompt, and then you refine that and compute rewards for that prompt, and then that basically goes through the traditional GRPO step. And this is kind of like the direction that things are kind of going, where we're kind of thinking about how to recurse, how to create these loops to try to further refine. Currently, the model that they tested this on is Nevatron H8BK, and we can see here that AIM 25 went from 2.2 to 9.7, which is this is a small base model. It's only 8 billion parameters. So in DeepSeek R1, we can see that it went up from 38 to 40. I mean, these is not like major gains, but you can see that there's this direction of how recursion could end up further improving, and especially with these traditional systems. And we can see the ablation basically results here, where we see that these mechanisms can be really further employed. So we just read the conclusion. We introduced iterative group policy optimization, a simple yet effective extension of GRPO that injects self-feedback signal into the outcome-driven reinforced learning for reasoning. iGPR replaces single-shot optimization with two-stage loop. Stage 1 samples multiple drafts and selects the highest reward completion as a feedback. And Stage 2 conditions on this best draft and applies the standard GRPO style updated refinements. This yields a dynamic self-conditioning, that's what they term the training context automatically improves as the policy improves, creating a bootstrap refinement behavior that is absent from conventional group-based objectives. This idea of kind of creating multiple stages, creating multiple iterations to try to further refine, we can kind of extend this further and just imagine like how things can go, where you have one thing that's fitting into another, and we can have this more and more recursive feedback loop. They go on to further state empirically, GeoPro consistently improves verifiable math reasoning across model families. Across 7 billion parameter, 8 being 14 billion backbones, iGPR outperforms vanilla GPR as well as strong baselines. I imagine that far as time progresses, there are going to be further refinements on these types of mechanisms. We're going to start seeing a lot more iterative mechanisms and iterative training runs. Currently, SFT is another very common fine tuning mechanism that's used a lot on these models. So we're going to start seeing a lot of these things start being rolled out into the later iterations of these models. Well, that kind of like sums it up for here on. I kind of think that the further direction this research is going to basically lead is kind of thinking about how we can further refine a lot of the existing mechanisms that we have to try to add additional stages and additional places where we can further make more further enhancements. Well, thank you guys. I hope you enjoyed this paper. Again, this is a new paper that was just launched today, led by Ali Hamatazada at Nvidia, and this is definitely going to help us, further refine and lead to more and more refined approaches when we're dealing with LLMs and trying to improve their base reasoning.